All right, we're going to talk about inverse function. So we're going to talk about it if it's just coordinates and if it's in an equation. So an inverse relation, interchanging the first and second coordinates of each ordered pair. So if we have ordered pairs, so here I have G is the coordinate 2, 4, 1, -3, 2, -2, 0. If I want to know G inverse, notice here that symbol is G to the negative first, I would just interchange these. 4, 2, 3, -1, 0, -2. There's my inverse. Now, if I have an equation, so if the inverse relation is defined by an equation, interchanging the variables produces my inverse. So if I have y equals x squared minus 5x, my inverse is going to be x equals y squared minus 5y. All right? So with that, we want to know if a function is one-to-one. So a one-to-one function, a function is one-to-one if different inputs give us different outputs. Okay, so if A does not equal B, then f of A equals f of B. You can kind of look at the flip side. If A equals B, then f of A has to equal f of B, right? They have to be the same. So for every input, there is only one output, and for every output, there is only one input. Very important, because we want to be one-to-one. If we're one-to-one, if our function's one-to-one, then our inverse is also a function, okay? The horizontal line test. So if you remember, the vertical line test was to determine if a graph is a function. The horizontal line test determines if it is one-to-one. So if it is possible for a horizontal line to intersect the graph of a function more than once, then the function is not one-to-one, and the inverse is not a function. So for example, here I have two graphs. So here's my first one. If I took every single horizontal line and drew it across this, I would never intersect it more than once. So this one is 1 to 1. Okay, so that's all the horizontal line test. So here my other one, if I took a horizontal line and I drew it, once I have one spot where it intersects twice, this is not one-to-one. Okay, so we've talked about inverses quite a lot. So, and we've talked about how to find the equation for it. So we're going to kind of do that, and then we'll kind of show that to R. So if I have f of x equals 2x minus 3, well, remember f of x is the same thing as y. Y equals 2x minus 3. What I'm going to do is I'm going to interchange my x and y. X equals 2y minus 3, and now I'm going to solve for my new y. So I'm going to add 3. X plus 3 equals 2y. I'm going to divide by 2. So y equals x plus 3 over 2. And so now I'm going to write it in inverse form. F inverse of x equals x plus 3 over 2. Okay? So if you can solve it and get it into as an equation, that is the best approach. Now it says, here I have f of x equals 5x plus 8. And I have f inverse equals x minus 8 over 5. I want to show or prove that those are inverses. Well, the way we do that is we want to look at this. We want to look at f of f inverse of x. And we want to show that that just gets us back to x. Okay? So what I'm going to do is I'm going to take and plug this in. So f of f inverse of x is going to equal 5 times x minus 8 over 5 plus 8. So when I multiply this, these are going to cancel out, leaving me with x minus 8 plus 8, which is x. That is the proof that those are inverses. So remember, when you're going to solve for inverses, interchange your x and y. Your x becomes y, and your y's become x. Solve for that new y.